of causal may influence the other. So let's kind of map this out. Now we're going to call this a causal model because I'm proposing causality. And, you know, like we said, I think mom's education is related to grades. Yeah, absolutely, right? That's kind of given. And we think school quality is related to grades. And I think studying is related to grades. That's kind of, all three of those are related. That makes a lot of sense. And that's kind of, the previous diagram had that. They were all related to grades. But instead, I think mom's education, well, like we said, you know, if you're a highly educated mom, you may, one, have more income to live in neighborhoods with better quality schools. And it may be more important to you to make sure your kid goes to a better quality school. So I don't think that they're just correlated with each other. I think mom's education has an effect on school quality. And if you think about it, it can't be the other way around because you live in, I mean, to say it's correlated without that direction, you're saying that mothers whose kids go to a good school decide to go back and finish their degrees. And in fact, technically, depending on when you got the data, you may have to go back in time and finish your degree. It doesn't make sense. Versus the alternative theory, the alternative model is educated moms live in better neighborhoods with higher quality schools. That seems much more plausible. But notice, the data doesn't tell me. SPSS won't tell me, oh, this is the way it looks. The data doesn't tell you this is the way it looks. It's up to your theory and your thinking. That's why you need to know the literature. You need to put some thought into it. But you're going to say, no, that's not a two-headed arrow. I think mom's education leads to school quality. And for the same reason, I think mom's education leads to study hours. Otherwise, it's like, okay, mom sees her child studying really hard and it inspires mom to build a time machine and go back in time and finish her degree or get a degree. Right, no, it's got to be this way. And you might even think, well, school quality, I think good quality schools, kids will study more in a good quality. So I think it goes this way. I don't think kids studying more makes it a better quality school, though maybe it does. Maybe people can argue which way that arrow goes. And I may think it's this way, and me may think it's the other way. And that's where we fight it out in the literature. And in essence, we're fighting over C. We're back to who's fighting over that little section of C. Who gets C? Is it study or is it school quality? And we're battling it out in the literature.
Can you not be both ways?
You could have it both ways. But the question with having it both ways is, are you copying out? Often people will have the two-headed arrows because they don't want to commit. They're just, dang it, have a theory. Back it up. If you truly think it's bidirectional, and that actually gets beyond this book to deal with two-headed arrows in the middle of a diagram. But you can make more elaborate models. But the key is think of what your model is. Don't be lazy and just say, you know what, I'm just going to do the simplest analysis and I'm going to do this. If that's not what you think is going on. If that's what you think is going on, that's great. Do that analysis. But if in your heart and in your brain, you're thinking, here you go, this is it. Do this analysis. And this is what we'll get into next week. Now, part of this, kind of continuing this, so you can kind of see this is much more elaborate. And again, kind of laying the seed work for the next few weeks. The groundwork. I'm mixing my metaphors. Planting the seed, laying the groundwork. You notice there's what we're going to call direct effects. Mom's education has a direct effect on grades. Notice there's nothing in between. Mom's education impacts grades. And that is, when we say that by direct effect, we mean that it's unrelated to school quality and unrelated to study hours. So if I statistically control for school quality and I statistically control for how much the child studies, mom's education still has a significant effect. There's other stuff going on that's not dependent on the school, that's not related to how much the child studies. Maybe it's genes, maybe it's how many books are in the house, maybe it's what you watch on television, who knows. But it's something, that direct effect is the effect mom's education has that's unrelated, uncorrelated with all the other predictors in the model. It's just the effect of mom's all on its own, beyond those. But mom's education has also what's called an indirect effect. I love indirect effects. This is where it gets kind of cool. That mom's education leads to higher school quality, and higher school quality leads to grades, better grades. So mom's education has an indirect effect through school quality is how we talk about that. Part of the effect of school quality is in fact due to mother's education, because the moms are getting their kids in better schools. And so this is, again, who gets the C? Where does C belong? Is it school quality, or should it belong to the mom? Is it part of the effect of mother's education getting her kids into a good school? This is what's called an indirect effect. That this leads to this, which leads to that. A leads to B, leads to C. We're interested in indirect effects all the time in education. One thing leads to some. A causes B, B causes whatever. Indirect effects can be hard to find because they're, and we'll get into this later, they're more subtle. You need bigger samples. But very interesting stuff. More on that later. One other kind of thing related to all of this, the mother's education and school quality are both what are called common causes of study hours and grades. What I mean by a common cause, to be a common cause, I didn't put that on this slide. So you'll have to write this down. To be a common cause, the variable needs to have an effect on both variables. It's a common cause for both of them. So that gets at the idea of, you can see, we were just talking about those indirect effects. Mom's education has an effect on study hours. It has an effect on grades. So if I don't include mom's education in the model, who gets the C? C goes to study hours. And it should have gone to mom. So I'm going to misstate what the effect of study hours is by missing the common causes. So regression is kind of one of the interesting things. People say that you'll hear people talk about. You need all the predictors of grades in your model. You need every variable that's related to grades in your regression model if I'm interested in studying. Let's see, my key interest is studying. And you'll have people say, and you'll get reviewers that'll say, well, this is related to grades, and this is related to grades, and that's related to grades, and you didn't get data on them. That's a problem if they're common causes. If they're not a common cause, you don't actually have to get them because it's not going to affect the regression coefficient for grades. Because remember, if it's not related to something, what effect does it have on those variables? If they're not related to grades and they're not related if they don't overlap with grades, whether or not they're in the model has no impact on the regression coefficient. It only has an impact on the regression coefficient if they're related, if there's that path. And if it's not related here, then, well, anyway. So common causes, you need all common causes for your variables of interest in the model. So that's important. And again, common causes have an effect on both of those variables. So what are the common causes of school quality and grades? What would be school quality and grades? So I'm interested in this relationship. What would be any common causes that I would need to include?
Mother's education.
Mother's education, right? Because it's mother's education is related to school quality, and mother's education is related to grades. So I'd have to, what about study hours? No, because study hours is not a common cause. It's an effect, but it's not the common cause of grades. I'm sorry, of school quality. So the common cause, if I'm really interested in school quality, I need to include mother's education. Now, I'm really kind of jumping ahead a little bit. If we didn't have study, you might think, yeah, but what if study hours is really important? Well, I'll still capture the indirect effect through study hours in school quality, but you'll miss what other stuff is going on there, but it won't mess up your estimate of the total impact school quality has. You just won't know that it was indirect. It'll be hidden. That indirect effect will be hidden in the school quality effect. Cool stuff. But again, we'll get into this later, so hopefully you're not just thinking.
I have a question. So with this model that essentially can impact what you're finding, how do you determine your understanding of the connection between them? Is that where you have to read literature, or is that like the paradigm that you're thinking about?
It's your brain. So that's why you need to be informed, you need to read the literature, you need to be able to defend it. I see that all the time, that people will, over the years I've done a lot of reviewing, and you will see reviewers arguing with people, that's the wrong model. Did you not read blah, 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 blah? And you have to come back and defend yourself.
So
no, this is why I think this is the model.
So even at the end of the day, even if you do your equations and set everything up correctly, it's still subjective in some way because
Yes.
you're using a model.
Ming and I are going to be fighting this out for years in the literature with different data sets and different approaches and different methodological approaches where Ming might do an intervention and he goes to the schools and says, you know what, I'm going to do an intervention and we'll randomly assign schools, and some schools will get these programs to increase study hours so that I can do a better, stronger test of that way versus this way. That's the fun of research, that people will be, but it's your theory. In the end, it's your theory.
So with quantitative research, is there common paradigms that people subscribe to, or like a system of believing a certain way, or is that just more qualitative research that?
Oh, I think all research has paradigms and ways of thinking. It's like, yeah.
But do you have to is there like any seminal literature that you have to cite or anything when you're doing this or writing this up, or?
You should cite whatever literature. So in this case, I would want to understand the school quality. I mean, you want to know the literature associated with your variables.
Okay. Because I'm just thinking, I'm like, if someone came in to do this, just equations wise, and they didn't know enough about any of these variables, they wouldn't know how.
And that's a fatal problem. You do not want to go into this and say, I'm a quantitative researcher, so I'm going to completely ignore all this other stuff that, kind of qualitative, whatever, saying. You would definitely not want to be a qualitative researcher and say, well, my paradigm is this and this. All those studies don't matter to me. Absolutely not. I mean, you're just asking to get rejected. No, you need to know the literature, and the literature is school quality. The literature is not a theoretical orientation. That's where people run into trouble all the time, that they I adapt a framework. I'm a fill-in-the-blank researcher, and I only read that literature. Then you're going to come up with crappy models.
So in theory, wouldn't you, I guess it's a larger question we don't need to solve tonight, wouldn't you assume then that most doc students would be trained in both qual and quant to have a better understanding of this?
Absolutely.
I'm just thinking, wouldn't
I think students it is a disservice for students to be given, your training has to
crossover to understand.
I mean, that's why a lot of, that's the benefit of a diverse, theoretically oriented school.
You don't want all your professors, think the same way, use the same method.
I mean, and it's once you think about it, of course, there's going to be awesome qualitative research on what makes good schools. And there's going to be awesome quantitative sort of data on what makes good schools. If you cut yourself off from something just because it doesn't fit how you find yourself, then Ming's going to kick your butt when he's challenging your theory out there, and he knows all the literature. You don't want him reviewing your paper saying you've missed these big holes. Your arrows are the wrong way.
But that theory sometimes it doesn't only come from literature. It can also come from a qualitative research as well, right? For example, if you go on.
Well, qualitative research is research.
Right.
Yeah, no, I'm not using the term research to imply that it must be quantitative.
No, I mean, it doesn't have to come from like secondary data, right? Or literature. It can come from, for example, you can do a literature review, and at the same time you do like a qualitative study to inform the
Yeah.
type of variables you're going to choose.
Yeah, no, that's all research.
Mixed method.
That's all good research. It's.
Well, that's. Thank you. That was helpful. I'm sorry we got off on a tangent, but it
No,
helps
that's an important
connect the
tangent.
lines between the two.
That's an important
And
tangent.
it shows that on some level it can definitely be subjective.
Oh, yeah.
When you're setting.
And you
these models.
and it's all in the end, all models, all theoretical orientations are subjective in the sense that you're picking. The data doesn't tell you what to do. The more informed you are on the content, the better models, the better answers you'll have. You should never. You don't want to cut yourself off from any body of research.
I mean, are you posting this on in public? Because I wanted to say something that.
Well, let's come back to that at the end.
Yeah.
So let's keep going.
It's 7:26, so you only have 4 minutes.
Oh, dang it, I was about to catch up. I thought we were going to catch up today. We can, because the last little bit, which is really kind of cool stuff, is completely for your own edification. So it's not on assignment 3. So when assignment 3 posts in 4 minutes, we'll still be okay. So thoughts on adding predictors. So one other thing is we've talked about adding variables. As we saw, adding additional variables that are correlated with other variables in the model will change your regression coefficients. We just saw that with school quality. So it's important to keep that in mind, and that you're not leaving out something that is important, because otherwise you're going to report biased estimates. Typically, leaving out important variables. Typically as you add variables, it will make your effects look smaller, because think of the Venn diagram, you're kind of overlapping more and more, and there's less and less. So typically as you add variables, your effects may become smaller and harder to detect, which is one reason people don't like doing it. It can make your effects look bigger if you get there's weird sorts of relationships we'll talk about later sometimes that can come up in ways that you'll often see in clinical intervention sort of work that can be confusing to interpret. So we'll talk about that later, but it's good to recognize that. We've already talked about the limitation of statistical control versus experimental control. Again, experimental control is superior. As much as I like statistical control, this gets at the very issue, what do you include? Because if I'm not able to randomly assign everybody into conditions, then you have to start worrying about what might be related to something. Too little statistical control and you risk overstating your effects. If you didn't include mother's education, you're going to say was it studying hours that you're going to say something has a big deal and it doesn't. That's not good. Too much statistical control and you can inappropriately understate your effects. A great example of this is years ago, Chopin knows where I'm going with this. I was on one of my early dissertation committees with someone who I really enjoy. I still work with this person to this day periodically. She was a former student. Not of mine, but I was on the committee. Anyway, was looking at predicting effects, early childhood effects on, like birth-related effects, on future special education placement. What risk factors in the early childhood place children at how much risk for ending up in special education. And she threw everything into the model. She controlled for mother's education, marital status, income, whatever, all these variables. And the end result was found that being a teenage mom was great for your baby, controlling for everything. But the problem is, when you think about it, but there were no highly educated, college graduate, high income, living in a great neighborhood, going to great schools, 14-year-old moms. She essentially, I talk about is you kind of statistically partial yourself out of existence. You start talking about a population that doesn't exist anymore. And again, when we're thinking, well, this idea of, remember, when you do the statistical control, you're not talking about behavior anymore. You're talking about behavior after controlling for. You're talking about behavior that's unrelated. What is special education when you removed a huge chunk of the variance anymore? You're not talking about that anymore. You're talking about something else. So too much statistical control can cause its own problems. What are you talking about anymore? And controlling for all those things, does that even make sense? Because it's not experimental. You're not able to go in and say, you're a 14-year-old mom, here's a PhD, here's a $500,000 home for you and your child, and a relationship with a significant other that's going to last for whatever. You can't experimentally control for things, and that's the issue again. We're not doing experiment. This is pretend. Statistics is pretending as if we're able to do that. One last slide, then I promise I'll stop. Additional thoughts, interpreting effects. There's a variety of different measures of effects. Unstandardized regression coefficient, standardized regression coefficient, R squared, delta R squared, that's change in R squared. We'll get it next week. These are all measures of effect. People lose sight of that. You'll often see people will think of only R or whatever as a measure of effect. These are all measures of effect. Don't judge an effect based on its p-value. A small p-value does not mean it's a big effect. It just means it's not very likely. That it's not very likely that it's not a real effect, but it tells you nothing about how big the effect is. It just means it's rare that you would have seen an effect if there wasn't something there. But it can be as small. You can get teeny tiny effects with incredible p-values if your sample's really big. So do not judge the size of an effect based on the p-value. People make that mistake way too often. Here's some examples of what's a small, medium, or large effect. These are kind of Cohen's guidelines. Another measure effect, F squared. It's not the F test, F. This is something else we'll talk about later. But kind of how much variance accounted for, how much are R squared in multiple regression. These are kind of some standards you'll see. But again, it has the same issues we've talked about. Am I getting my class? We talked about it's kind of small, medium, large. The same issues. What's small really depends. I hate kind of these guidelines because if you're looking at a statistical interaction, which we'll talk about later, or curvilinear effects, which we'll talk about later, sometimes they can't be anything other than small, and they can actually be very big relative in an impact way. They can be very big, but only account for a small amount of variance. So you'll see these guidelines, you'll hear people talk about it, you'll get people that will tell you they want to interpret your results based on them, so you need to be aware of them, but don't just fall into the trap of, oh, it's big, oh, it's small. Look at the bigger picture, as we've previously talked about, and we'll continue talking about, okay? Thanks. We're caught up.